Understanding Algorithm Growth Part 2. In this video, we will demonstrate how to calculate the runtime of an algorithm. What is runtime? Runtime is the number of statements executed by an algorithm or method as a function of its input size. Knowing an algorithm's runtime is what allows us to classify it as either constant, linear, quadratic, logarithmic, or something else. That being said, although it's called runtime, and although there is a picture of a timer above this text, we don't actually time the code. The picture of the timer is just there to reinforce that we're counting something, but we're not timing the code. The reason we don't time the code is because time depends on what machine you're using, what type of internet connection you have, which programming environment you're using, and a bunch of other variables that have nothing to do with the code itself. For these reasons, it's possible to run the same code in two different environments but get completely different times. Either because the machine is different, or the internet connection is different, or the compiler is different, etc., etc. So, how do we calculate the runtime? Well, there are three different types of statements we have to account for. First is the sequential statement, which is basically any statement that's not inside a loop or an if statement. These statements we simply count as one statement. Whether I'm printing out a value or declaring a variable or initializing that variable or executing a mathematical expression, etc., one line of code will simply count it as one statement. Now, you might be wondering, what if more than one action is happening in this one line of code? For example, what if we're declaring a variable and initializing it to a value all in the same line? Couldn't we count that as two statements or two actions? And the answer to that is you could. And neither approach would be wrong. But as you will see as we progress further into the unit, neither approach makes a difference in terms of what the larger picture and what the larger goal is for this unit. And that'll become clearer as we progress further into the unit. What I'm doing now is simply establishing the norms for our class, just so that we can be consistent across the board. But also don't be surprised if you find out that other classes may have slightly different norms. That's okay. We're all still learning the same thing. That being said, we discussed sequential statements, which is again any statement that's not in a loop or an if statement. Next, we will discuss how to count for and while loops. How do we count for and while loops? Well, we count those by first counting the number of loops, then multiplying that number times the number of sequential statements inside of that loop. And we don't count the loop header. Not because it would be wrong to do so, but we just don't need to. Next, if statement. How do we count if statements? We count them by first assuming that the condition is true. Then we count the number of sequential statements inside the if statement. We don't count the Boolean condition. Once again, not because it would be wrong to, but because in terms of the larger picture, we don't need to. And then last but not least, if-else statements. When we encounter an if-else statement, count the branch and only the branch that has more sequential statements. We know that we're never going to execute both the if branch and the else branch, so rather than count both of them, we'll just count the longer of the two. Because when analyzing algorithm growth, the worst case scenario is the scenario we are most concerned with. That all being said, just to summarize, once again, this is a simplified approach to help us build a basic understanding. Technically, we could count things like the loop header, the Boolean condition, and we could try to predict how often the Boolean condition will be true or false instead of just assuming it's true. And we would not be wrong to do that. In fact, there are situations where paying attention to that level of detail is absolutely necessary. But we're not going to encounter those situations in this class. For this class, those details don't change the bigger picture of what we are focusing on, which is algorithm growth. Trying to count every detail right now would only make the unit more confusing, so instead, we'll save that level of analysis for future computer science courses. Now, on to the examples. Here we have a method named printNum that receives a single integer as its parameter, n. We'll call that the input. And inside the definition, we're simply printing out the value of the input. There's one sequential statement inside this method. what would be the runtime for this method? Well, since there's only one sequential statement and nothing else, the running time for this method would simply be 1, since it only executes one statement. Here's another example. This time the method has 3 sequential statements. Henceforth, the running time would simply be 3. Here's a third example. Now we have 5 statements. We have 5 sequential statements. So in this case, the running time would simply be 5. Fourth example. Now we have an if statement. How are we going to count this? In this example, we have 1 sequential statement and 1 conditional statement. And by conditional, I mean the statement that's inside the if statement. And we're going to assume that the Boolean condition is true. We don't need to count it because once again, we're analyzing based on the worst case scenario. Henceforth, since there are only 2 statements to count, the running time would simply be 2. Fifth example, now we have an if-else statement. How are we going to count it? Well, the method starts off with 1 sequential statement, int x equals 5. Then we have an if block that contains 1 conditional statement, and an else block that contains 2 conditional statements. And since we know that only one of these blocks can get executed, and we're focused on the worst case scenario, we're going to count only the block with more conditional statements, which is the else block, which contains 2 conditional statements. So our total runtime will be 3. Next example, now we have a for loop. How do we count the for loop? We're going to do that by counting the number of times that the iterative statement, or the statement within the for loop, will get executed. Judging by the loop header, we know the for loop will execute n loops. And we also know that the loop contains just 1 iterative statement. Henceforth, the running time will simply be 1 times n, which is n. Next example. Here we have another for loop, but this time it contains 3 statements inside the for loop. How do we count it? Well, once again, by looking at the loop header, we know that the for loop will execute n loops. And we also know that the loop contains 3 iterative statements. Henceforth, the running time for this method will be equal to 3 times n, 3 times the number of loops. Next example. Here we have another for loop that contains 3 statements, but also there's another sequential statement outside of the for loop. How do we count it? Well, let's first count the for loop. We know the for loop executes n loops, and we know the loop contains 3 iterative statements. Thus, the number of executed statements within that for loop will be 3 times n. Then, on top of that, we know there is 1 sequential statement outside of the loop that'll be executed only once. Put those together, the total runtime, 3 times n plus 1. Next example. Here we have a while loop, and there are 3 different statements that we need to determine the number of times they're going to be executed. Judging by the initial value of I, the loop condition, and the increment statement, we can determine the while loop will execute n loops. And we know that the loop contains 2 iterative statements. And we also know that there is just 1 sequential statement outside of the loop that'll be executed only once, the int I equals 0 statement. Put that all together, our running time would be simply 2 times n plus 1. Next example. Here we have a nested for loop and only 1 statement that we need to worry about counting. Looking at the outer loop header, we know the outer for loop will execute n loops, and the inner for loop will execute n loops as well. And both loops contain just 1 iterative statement, the same iterative statement. Thus, the number of times that 1 statement will be executed will be equal to the product of the number of outer loops times the number of inner loops, which is simply n times n, or n squared. And for our last example, we once again have a nested for loop, however, with 1 key difference. We have 1 statement that's only inside the outer for loop, and another statement that is inside both the inner and outer for loops. Okay. So the outer for loop we know executes n loops, And the inner for loop, we can tell, again, by looking at the header, will also execute n loops. The first print statement, which is only inside the outer for loop, will be executed n times, whereas the second print statement, which is inside both the inner and outer for loops, will execute n times, or n squared times. Put both together, and then for our final running time, we get n squared plus n. For our next example, we have another while loop, but with a few subtle but important differences. The first one being that instead of initializing I to 0, we're initializing it to n, the size of the input. Also, for the loop condition, instead of stopping it once it reaches n, we're stopping the loop once it's no longer greater than 0. Then, inside the while loop, instead of incrementing or decrementing the variable by 1, we're dividing it by 2 every single time. So now that that is out of the way, let's begin our analysis. So we have one sequential statement outside the loop, so that's going to count as one statement. Then for the while loop, since I is initialized to n and then gets divided by 2 during every single loop, the number of loops is going to be approximately log base 2 of n. That's going to be the number of loops executed. Note that this is an approximation, not the exact amount. The exact amount would actually be log base 2 of n plus 1. But for the purposes of this course, it'll be enough to just simply say log base 2 of n. Then last but not least, the number of statements inside of the for loop is 2. So multiply 2 times the number of loops plus the one sequential statement. Then for f of n, we get 2 times log base 2 of n plus 1 as our final running time.